Okay, let's talk about the chain rule. First, you need to know when to use the chain rule. Okay, so anytime you have a function, right, nested within another function, you want to use the chain rule. Okay, so for example, here we have the function g of x within the function f of x. If you recall from algebra 2, this was called a composition of functions. Okay, so anytime you have a function nested within another function, you want to use the chain rule, right? So the chain rule says this: if you need to take the derivative of the function y, right? So the derivative of y would equal the derivative, right, of the whole function, right, or the whole expression, right, times the derivative of the inside function, okay? So this part right here is the derivative of the whole function or expression, okay? Now here's one thing you need to remember though. You have to leave the inside alone. You understand what I mean when we do an example. Just remember for this part to leave the inside function alone, okay? And then times the derivative of the inside function, right? So this is the chain rule right here. All right, so let's take a look at an example. Okay, let's take a look at another example. Let's say we have 3x plus 1 to the 50th power. First of all, let's take a look at why this is a function within a function. Let's say we have y is equal to u to the 50th power, okay? And we can say u is equal to 3x plus 1. Now you notice we have two functions here, so the function u, if we plug it in, substitute it in from right here, we end up with our whole function, our whole expression. Okay, so we have a function within another function. Alright, so now when that happens, we can use the chain rule. So the chain rule says this: to find the derivative of y, we take the derivative with respect to x of the whole function times the derivative of the inside function. Okay, so the derivative of this, so we can use the power rule for this, right? It's a corollary, it's called the general power rule that we can apply to this. So we'll get 50 times, now here's the important thing. Remember, for when we're taking the derivative of the whole function, you leave the inside function alone for this. So always leave this alone. So write it exactly as it is, and then we do 50 minus 1, right? We're just doing, basically you're just doing power rule right here. So you end up with 49 times, now the derivative, now we take the derivative of the inside. So times the derivative of the inside, which is going to be 1 times 3 is 3, right? And then so our derivative, make sure you clean this up, so we're going to end up with 50 times 3, which is 150, times 3x plus 1 to the 49th power. And you don't need to multiply this out to get a final answer. This is perfectly acceptable right here. Okay, so we've just taken the derivative of y using the chain rule. Right? And you see it's rather easy. Just take the derivative of the whole thing, right? Of the whole thing. Leave the inside alone though. Leave the inside function alone. Times the derivative of the inside function. Okay, so let's take a look at another example. How about y is equal to the square root of 13x squared minus 5x plus 8. Alright, so first of all, let's kind of rewrite this. So this is the quantity 13x squared minus 5x plus 8 to the 1/2 power, right? Same thing, I'm just converting this from a radical to exponent form. Alright, and then now let's use the chain rule, alright, because we have a function within a another function. Alright. to get the derivative of y. Alright, to get the derivative of y, we're going to take the derivative with respect to x of the whole thing, right? 13x squared minus 5x plus 8 to the 1/2 power times the derivative with respect to x of the inside, right? Of the inside, which is 13x squared minus 5x plus 8. So dy dx, derivative of y with respect to x is equal to, so use the power rule here, we're going to end up with 1/2, right? 1/2. And we keep this function here exactly the same. Do not change anything. Remember, leave it exactly the same. Minus 5x plus 8. Right, and then we have 1/2 minus 1, so that's going to give you negative 1/2. Right, so this is the derivative of this times the derivative of the inside right here, of the inside function right here. So we have 26 x minus 5, right? And then let's clean this up a little bit. So this is going to give us, so this is a negative exponent, so it isn't moved to the bottom. So the dy dx is equal to, we're going to end up with 26x minus 5 over 2 is in the denominator, right? And this moves to the bottom. 13x squared minus 5x plus 8. If you want to clean this up a little bit more, oops, that was to the 1/2 power. And if you want to clean this up a little bit more, 26x minus 5 over, changes back to radical form, square root of 13x squared minus 5x plus 8. And then this would be your answer. Okay? Let's take a look at another one. Let's see, we need to find the derivative of f of x is equal to 1 minus 4x minus 7x to the 5th (23rd) power. Okay, so we're going to use the chain rule here. So f prime of x is going to equal, so we're going to take the derivative of the whole function, right? 1 minus 4x minus 7x to the 5th to the 23rd power times the derivative, right? Take the derivative of the inside function, which is 1 minus 4x minus 7x to the 5th. So f prime of x is going to equal, use general power rule here, we end up with 23 times, keep the inside function the same, 1 minus 4x minus 7x to the 5th. 23 minus 1 is 22 times the derivative of the inside function, this right here. So we end up with, that's a 0, that's going to give you negative 4 minus 35x to the 4th. Okay, and then let's just clean this up. F prime of x is equal to 23 times negative 4 minus 35x to the 4th times 1 minus 4x minus 7x to the 5th, and then this is your answer. Okay, and this is your answer.